I feel really, I don't have a cool accent, and I'm not funny, so I'm okay. So I hope I'm not going to be as entertaining, but I will try really hard. So we're going to switch gears now, and we're going to talk a little bit about what's happening in the landscape of the remethylation disorders. So when I talk about remethylation disorders, I promised my husband I wouldn't use diagrams, but I'm really sorry. He hates checking over my diagrams. But when I'm talking about remethylation disorders, I'm talking about all of those disorders early on in the pathway, circled in red. So we're looking at all of the cobalamin disorders, severe MTHFR, that cause homocystinuria. So the exciting thing about the remethylation landscape is that we are starting to see a lot more of the cobalamin disorders represented in the scientific world. This year we were at multiple scientific conferences, and we saw, there's only 3 here, but that's exciting because normally there are none. Yeah, so 3 related posters, scientific posters, with research related to cobalamin disorders. One that you'll hear about from Irene regarding the hydroxycobalamin dosing. We had some case studies of new patients being diagnosed. It's exciting to see that metabolic doctors are starting to recognize the symptoms of cobalamin disorders and seeing those patients diagnosed through their clinics. So we went through the 2023 global grant process. You heard a little bit from Margie about how that process works. 2 years ago, I stood up in front of you guys and said we just finished the research map, and it was very exciting. So now we're going to start the next phase, and that's been completed, and it's very exciting. So we compiled a scientific advisory board with members all over the world who could give us advice on who to fund for these grants. So we were able to provide 2 grants last year, put the call out, and said we want to fund a research project for severe MTHFR and cobalamin G. Now that is very specific, and I'll tell you why. The families that raised the money for these grants, there was only 4 of us. 4. And so we were pretty specific about what disorders we were going to be funding for that reason. In the future, we're hoping more families fundraise with us, and we can do more broad calls. But these grants were specific to severe MTHFR and cobalamin G. So we did end up having 4 applications for these grants. We had requested full proposals, which is just a lot of scientific talk. Thank goodness we have the SAB that can explain it all to me, because it was a lot. And on here you can see, I know they're kind of small, but these are the members of our scientific advisory board. They are all on our website if you'd like to check them out. The SAB then looks over all these full proposals, and they give us detailed feedback on each one of these proposals. So it's not just me deciding who gets this grant funding, it's an entire team of individuals. And we had other family representatives also included in that conversation as well. So we had this big Zoom call in September, which is incredibly hard to schedule when you have people with like a 16-hour time difference change. So thankfully, some of our members of the SAB woke up at 3 o'clock in the morning to have that Zoom call for our decision-making meeting. And this is some of the criteria that we looked at to evaluate. Just, what are we looking at when they submit a grant proposal? What are we trying to fund for projects? We want to know has this project already been done? We don't want to duplicate research because our funds are small. We're a small community. It's hard to fundraise, and the money that you fundraise or donate, we want to go to the best possible project. Is it clearly defined? Is it feasible? Can it even be done? Does the researcher who has requested these funds have the skills to carry out the project? Does the project have the potential to change the treatment approaches, quality of life for patients? And can it be implemented in a reasonable time frame? And of course, we look at its strengths and weaknesses. So the first project that we are very happy to have awarded, and maybe you've seen our notifications online, but if you haven't, we awarded $25,000 to Dr. Brian Gilfix, and he's at McGill University. Some of you may know Dr. Rosenblatt. Does that sound familiar? He works with Dr. Gilfix, but he does a lot of diagnostics for cobalamin disorders in Canada. So his project aim is to identify the use of specific antibiotics to allow for the full expression of proteins in patients, specific with stop mutations in cobalamin G. So a stop mutation just means that there's no expression of that protein at all. And he actually is currently working on this project for cobalamin C. And so this isn't just applicable to G, it's also applicable to many of the other cobalamin disorders as well. So we received a research update, even though we haven't quite hit 6 months for the funding of this project. But Dr. McGill is excited about how this project has been going and gave me just a really quick update. One of those published papers, actually at one of the scientific meetings, was actually his. He's actually been able to identify more mutations for cobalamin G, meaning expanding the possibility for this research project beyond what we originally thought. He's identified different drugs that could allow for the codon read to occur, which are listed here. And he's really also working, even though we're not funding this part of the cobalamin C research, but really focusing on finalizing some of those assays for the cobalamin C as well. The second project that we were able to fund is in Zurich, in Switzerland, and this is Dr. Ferdinand von Mayen. I love saying his name, he's great. So he actually just submitted a grant for severe MTHFR, and we were like, well, we really like this idea, so can you expand your project a little bit for us? And so he agreed to expand his project from severe MTHFR to also include cobalamin G. And again, this can be and is going to be applicable to other cobalamin disorders as well. So he's going to create what's called a cerebral organoid. And I truthfully didn't know what that was. I had to Google it. But basically, I mean, in my mind, I was picturing like a tiny little brain, you know, in a petri dish, but it's much less boring. It's more boring than that. So it really is just a group of cells in a petri dish, but they are they're neurological cells. And so the reason he's using a cerebral organoid is because we know that in cobalamin disorders, in severe MTHFR, a lot of the very serious complications come from degraded brain tissue, from issues neurological. And so he's really trying to make sure that whatever can occur will also happen in those cerebral brain tissues. So what he wants to do is he's going to create these cerebral organoids for both severe MTHFR and cobalamin G. He's going to help us understand the mechanism of the metabolic function, which, if you know, we don't know a lot about how all of these proteins interact and what happens in the brain and different parts of the tissues and muscles. So really doing exploratory as far as how is this occurring in cerebral tissue. And then in addition to creating these cerebral organoids, he's going to take potential therapies and screen them through these organoids to see, again, are there any small molecules that can target and support the production of these enzymes, of these proteins, and can it rescue and help the cerebral tissues and your neurological function. So that is his project. And right now, his timeline, he's really in the phase of creating these cerebral organoids, changing the DNA in these cerebral organoids to reflect the disorders, and then he will continue with his testing for the therapies. So his next steps are completing the cell line for cobalamin C, generating the organoids, and then running them through all of those compounds. From what I understand, there's like a data bank that you can pull from with all the known small molecules, and he will use that and screen a lot of information through those organoids. So what happens next? So this is where y'all come in. We need to continue to fundraise. Like I mentioned when I first came up here, these 2 grants were done primarily by 4 families. And it took us years to fundraise this money. And we don't want to let years now occur again until we can fund our next project. We want this to be snowball at the top of the mountain that's just going to keep building and building. We see all the amazing work that classical homocystinuria has done through raising funds for research, and that's what we want next. We want to be that. Next conference, I want our researchers here explaining amazing progress and breakthroughs and then more funding of more research. So please help us with the race for research. Please help us fundraise. Reach out to me if you have any questions. We'd love that. Stay tuned. Make sure you're signed up for our newsletter because we will update you on these research projects. We are especially going to be needing patient support if anything ends up going into clinical trials or we need patient support and feedback. So please stay tuned to what's happening, and we will definitely let you know, because any new discovery is really only going to be successful if we have patient support. And you know that our community in cobalamin disorders is very small. So we really need to band together and make sure that we are supporting these projects and are incredibly hopeful for the future. So thank you guys so much. I really appreciate it.